All right, so continuing with our discussion in chapter 3, we want to look at some more applications and using molar mass. I want to start by just looking at all of the conversion factors that we talked about last time, counting units, moles, kind of get us all back up to speed. So we know in chemistry we can use molecular formula to go back and forth between molecules and atoms. This allows us to change what we are counting, what the actual substance is. Are we looking at, say, carbon atoms or ethylene glycol molecules? But still, we're still counting just what we are counting. We then also have the ability to change how we count things. Do we count individual molecules or do we count them by groups, which comes in Avogadro's number, right? Which defines a mole. This is our common counting unit in chemistry, where we deal with large numbers of atoms grouped together to make more manageable amounts. We can use this mole and still apply the molecular formula conversion factors that we used previously. You can convert between counting what you're counting, either in this case we looked at sulfide ions or aluminum sulfide formula units. We can change those, but still counting in moles. So that molecular formula that we learned about still applies in the mole counting unit. Or if we were talking about dozens or gross or whatever, of any counting unit would always still apply. The conversion factor of atoms in a group would still apply. We then also can define the molar mass, which lets us convert between moles and grams for a substance. This is a conversion factor that you have to compute yourself, may be given to you sometimes, but you can't look at the molecular formula, and it's not just always Avogadro's number. You need to maybe do a little bit of calculations using our good friend, the periodic table. Importantly, this lets us change how we are describing a sample of matter. Are we counting individual objects by group, or are we just looking at total mass? Those are distinct ideas in how we're counting a given substance, and a given sample of a substance. So, put them all together, molecular formula, Avogadro's number, and molar mass. These are the three types of conversion factors that we have learned. They each accomplish something unique. Molecular formula lets us change what we are counting. Is it the atom? Is it the molecule? Avogadro's number lets us change how we are counting it. Is it groups, one mole at a time, or is it individual atoms and molecules? Finally, molar mass lets us convert between how we are describing an amount of a sample, either in mass or in moles. Molecular formula, unique for a compound, but always given to you. Avogadro's number, always the exact same number. Just need to look it up. Molar mass is unique for a given compound and may need to be computed using the periodic table. So let's do a hard example where we're going to put all of these things together. How many hydrogen atoms are contained in 45.6 grams of methanol, which is CH4O? Still want to start by asking, what do we want? Hydrogen atoms. We are looking for a count of atoms. Okay, we're looking for a count of actual atoms. So this is going to be a counting unit of hydrogen atoms. What do we have? 45.6 grams of methanol. Okay. We want to think about how we can relate these, and we can think about what is different between them. So the first difference we can see, this is hydrogen, this is CH4O. Those are different substances that you are looking at. So right away, we would imagine we're going to need to use molecular formula. We are definitely going to need to use a molecular formula in order to relate those two different ideas. Molecular formulas only work in counting units. We also have 45.6 grams. Let's change that color. 45.6 grams, whereas in this case, we want atoms. So there are certainly a distinction that 45.6 grams is a mass measurement and atoms is a counting measurement. So we are going to need to go between that mass description and a counting description. There is no direct conversion from grams to individual atoms. So we're going to need to take a stop off through moles. Whenever you have grams, you're always going to want to turn it into moles. And in fact, if ever you have an amount in grams, you really can't relate that to anything else. Molecular formula, Avogadro's number, all these things only work in counting units. Grams really can't do anything with, can't relate it to anything. The best idea is always going to be calculate a molar mass, convert from grams to moles. So molar mass of methanol is definitely going to be one of the things we want to compute to go from mass to moles. Avogadro's number is going to let us go from that moles count, right? We're dealing with moles here, to the individual total count that we're after, actual objects. And finally, molecular formula is going to let us change how we are counting those two things. So this is a complicated conversion. This is a complicated process where we're changing a lot. But each individual step is the things that we've seen previously. Molar mass of methanol, Avogadro's number, molecular formula. Those are the three things we learned about last time. Now we just want to put them all together into one difficult problem, but still it's just a lot of steps where those steps are things we've seen previously. So let's go ahead and work it out. All right, so how many H atoms are contained in 45.6 grams of methanol? So I want H atoms, and I'm given 45.6 grams of CH4O. So this is a pretty, if we look at what we're getting at, we start with the 45.6 grams of the CH4O. And you can see that what we want in the end is H atom. And when we go through and look, we can see we have different substance, CH4O versus the hydrogen. We can also see that we have, in this case, a mass measurement, in this case, a counting. So those are two different types of measurements. Grams are really common to get. It's very, very common to get grams as we move forward because that's what we measure. And so we can, and in the lab, that's what we'd measure. So this is really, if we are faced with having grams, the good first step in this chapter 3, moving forward as we move into chapter 4 and chapter 5, where we do this again, it's going to come back in chapter 9. If you're given grams, really just convert the mole, calculate the molar mass and convert it into moles. That is going to always be a good first step. So we're just going to say now, in this case, the molar mass, I looked it up, calculated it, was 32.05 grams per mole. Along those lines, a lot of times, some problem, like we saw in the last set of videos, there's a lot of me really calculating the molar mass or asking you to calculate the molar mass. As we move into some more complicated problems, I'm going to kind of expect, not necessarily ask you to calculate it, I'm going to give it to you a lot more. And that's because I'm going to expect you to use the molar mass that you're given because I want to see, can you do that? There'll be some problems where I ask you to compute it yourself or expect you to know you need to compute it, right? I want to test you on that side of things. But here, I'm just going to give it, I'm just looking it up, or I would give it to you a lot in problems. So let's go ahead and write that part out. We use the 32.05 grams, right? We keep the grams, the number next to the grams, and it's a 1 next to the mole, because that molar mass is per mole. So that's great. So from there, I'm in moles now. And so I'm closer, I'm in a counting unit, so that's good. But I still have the wrong substance. This is CH4O, I'd prefer H, and I'm in moles. So I still have an issue. Now I'm in moles, and I want individual objects that I'd be counting. So I need to do another conversion on that one. And I can use my molecular formula, and I can use the fact that there are in 1 mole of CH4O, I have 4 moles of H. And that 4 comes from the subscript in the molecular formula. So that's great. Cancel out moles of CH4O. I'm now in moles of H. And we got rid of our grams previously, which was good. So now I have the right substance, so that all checks out. That's good. The only thing I need to deal with now is the fact that I'm in moles and I want to get to atoms. This is still a count by group. I want individuals. And in order to do that, I know that I need to use Avogadro's number. So we're going to run out of room, but that's okay. 1 mole of H is 6.022 times 10 to the 23rd H atoms. So bin that one off. Common theme. This was a long problem, lots of space. But we can see that very nicely. We went ahead and got rid of the moles. So if we put all of that together, these are exact. That is 4 sig figs for 3. So that gets me 3.43 times 10 to the 24th H atoms. And we can see that what we're doing is we're using molar mass, which we compute. We're using the molecular formula. And we're using Avogadro's number. And we end up with just a number of hydrogen atoms in the end. So 45.6 grams CH4O has 3.43 times 10 to the 24th hydrogen atoms. Participation 6.8, question 5. What is the mass of 1.5 times 10 to the 24th H2O molecules? This is the 5th question on participation 6.8, due Monday, June 8th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, what is the mass of 1.5 times 10 to the 24th water molecules? Okay, 5 questions on participation 6.8. You want to find all 5 of those questions, get them answered, and get those answers submitted over on Blackboard by Monday night. We'll have the Tuesday participation due, and then the Module 3 homework will cover both of those. That material, what's Module 3 material, will be the end of what will be on Thursday's exam. Again, there's a review in the Exam 1 folder that you can submit for 3 bonus points. If you have any questions or want me to talk about the exam material, let me know. Otherwise, before the start of lab on Tuesday, you also have the pre-lab, the technique comprehension due, and then the notebook needs to be set up. You want to rotate the members of your group, who's going to be the technician, who's going to be the leader, and get that stuff set up beforehand. Other than that, we've got the rest of the week, Thursday lab, Thursday, Friday participation. There will be the answers to the participation that go live Monday night for this set of videos. If you have any questions about anything, let me know. Otherwise, enjoy the rest of your day. I'll see you later this week. Bye-bye.